when you're doing a question like this, the first thing you need to do is know the point where the tangent's going to be, and then you need to find, using the first derivative, the slope of the tangent, find the equation of the tangent, and then we've got one extra bit and we'll have to find where it cuts the x-axis. Okay, so if we start by looking at this thing over here, alright, so with my so the thing that I need to do here is I need to say when x is equal to 0, y is going to be equal to ln of 0 squared plus 3. So that's simply just going to be ln of 3. So my point is in fact 0 ln 3. That's the point I'm using. I need to do my derivative, so dy dx, and that's going to be equal to, well, I don't have to think about it too much. I just simply put that over the bottom line there, and then I just have to drive the top line, which is equal to 2x. So that's pretty easy to do the derivatives for these things. Now, the next thing is I know my tangent, when we're looking at that thing there, we have to find the slope of the line when that's equal to, when x is equal to 0. So that's equal to, simply, or I should probably set it out properly, when x equals 0, my dy dx is equal to simply 2 times by 0 all over 0 squared plus 3, which is equal to 0 on 3, which we would say is 0. That's easy enough. It's good when you get a 0 for a slope, because then it just means that my equation on my line is in fact equal to what? Just equal to my y coordinate, isn't it? Well, let's do it the long way. Y take ln of 3 all over x take 0 equals 0. When I times this up over here, I've got y take ln of 3 is equal to 0 times by x take 0. Now that is 0, isn't it? So therefore, y equals ln of 3. Now if I did want to save some time, I could just simply go straight to that answer, can I? So that's my equation, my line y equals ln of 3. I don't know what that actually is equal to. It's about 1 point something. Now, the thing is, the question says, where does that cut the x-axis? So when does that cut the x-axis, that line y equals ln of 3? When does that cut the x-axis? When's that ever going to, when's x going to be equal to 0? The answer is, I don't know. I don't know.
You don't know.
I do know, but I don't know if you know. That's the question. Oh, well, what would a line like this basically represent? Okay, so if I did a line which is ln of 3, that would be a line like this, wouldn't it? That goes y equals ln of 3. Isn't that what that's actually equal to? When's that going to cut the x-axis? Never. It's never going to cut the x-axis, is it? Alright? So essentially that last little bit was a bit of a trick for you. Alright? So it's a never cuts x-axis. And by in fact sketching it sometimes, that's a really good way of showing that you actually understand what's going on. Alright, with that. So essentially when we're doing a question that is like this, and you've got some of those at the start of 5E, alright, what we've got here is to go through the process. The process is simply, alright, we find the point, we find the slope, okay, at that point, and then we still do the same process what we've done before. Y take the y coordinate, x take the x coordinate equals the slope. And we just rearrange that. Now, if you have 1 over e's and all that sort of stuff, that makes it tricky, but it's not impossible. Alright? Just two things before I let you go, is if I get something like e to the minus 3, I'm expecting you to write this as 1 over e to the 3. You understand that they are the same using my indice laws? Okay, so if I've got something like that, I would expect that you will write that in that particular form. If I've got something like e to the minus 1, I'm expecting you to write that as 1 over e. If I've got 1 over e squared, actually I made a mistake with that, just cross that out. If I have 1 over e to the minus 2, then I'm expecting you to see that as actually e squared when you bring it up to the top line. Okay, you want to write them as positive powers if you can with that.